The quotient rule. We are going to derive the formula or the quotient rule of differentiation using the functions f of x and g of x. The derivative of f of x over g of x is equal to the limit of f of x plus h over g of x plus h minus f of x over g of x all over h, as h approaches 0. H here is the change of f of x and g of x. Since this is a complex fraction, let's simplify the upper by having the common denominator, cross-multiply g of x plus h and g of x and multiply 1 over h to the whole fraction. So it's equal to f of x plus h times g of x, minus g of x plus h times f of x, all over h times g of x plus h. From here we are going to add between the two terms, minus f of x times g of x plus f of x times g of x. Then factor out g of x and negative f of x and bring up 1 over h. Notice that this part is the derivative of f of x or f prime of x, and also this part here is the derivative of g of x or g prime of x. And in the denominator, because limit of h approaches 0, leaving here g of x times g of x. So the derivative of f of x over g of x is equal to g of x times the derivative of f of x or f prime of x minus f of x times the derivative of g of x or g prime of x all over g of x squared.
Here 17 and 13 as Curry bangs home the two-pointer.
Let's derive the formula using function u and v. The derivative of u over v with respect to x is v du over dx minus u dv over dx all over v squared. Let's try deriving this using the product rule of differentiation. So let y equals u times v to the power negative 1. By product rule, we have u times the derivative of v to be power negative 1 plus v to the power negative 1 times the derivative of u all with respect to x. The derivative of v to the power negative 1 is u dv times negative 1 times v the power negative 2, due to power rule, plus v the power negative 1 times du. To make the power positive, bring down them in the denominator, so negative u dv over dx over v square minus du over dx over v. Because v squared is the common denominator, multiply v to du over dx. Since v du over dx is positive and u dv over dx is negative, then interchange their positions. So the derivative is equal to v du minus u dv over dx all over v squared. To summarize this, the product rule states that the derivative of dividing two functions is equal to the divisor times the derivative of the dividend minus the dividend times the derivative of the divisor over the square of the divisor.
James down low, double team, through some contact, count it, and 1.
Example y equals 4x minus 5 over 2x plus 1. Here u is 4 minus 5 and v is 2x plus 1. So du over dx is 4, and dv over dx is 2. Let's substitute to the formula v du over dx minus u dv over dx all over v squared. So quantity 2x plus 1 times 4, minus quantity 4x minus 5 times 2, over quantity 2x plus 1 squared. Distribute 4 and 2, so 8x plus 4 minus 8x plus 10 over quantity 2x plus 1 squared. 8x minus 8x is 0 and 4 plus 10 is 14. So the final answer is 14 over quantity 2x plus 1 squared.
Last of the official. This defensive play.